Okay, good afternoon, everybody, and thank you for attending today's webinar on inspirational global projects with our Vice President of Design and Distributor Sales, Laura Robertson. My name is Brian Yansak, and I am the Design Studio and Events Coordinator for Glen-Gery. During the presentation, you will notice the Q&A function at the bottom of your screen. Please feel free to submit any questions throughout your presentation, and they will be answered at its conclusion. Your attendance will be marked, and we ask that you stay on for the duration of the presentation to receive credit. Everyone attending the duration of the course will be receiving a certificate of completion within the next few business days, and those who provided their AIA number during registration will be submitted for AIA credit as well. If you're participating but did not register and wish to receive credit, please email your AIA number to events@glengery.com. That is events@glengery.com. With your information, I'll be happy to make that happen for you. Today's session will also be recorded, and a link for you to access it will be provided within your certificate of completion. Speaking of recordings, unfortunately, our speaker today is a little under the weather, and she is saving her voice. So we will be showing a recording of the same seminar that took place last spring, so please ignore the incorrect date, but I promise it's the same information, and she is live on the call today so she can answer questions at the conclusion of the program. With that being said, I would like to introduce our speaker, Laura Robertson. Laura is an experienced ceramic engineer with a demonstrated history of working in the building materials industry, specializing in the manufacture, design, and construction of clay, glass, and concrete products. Beginning her career in Australia, Laura has held roles in research and development, technical sales, business development, and national design and specification, collaborating with architects on a number of award-winning projects before relocating to the United States in November 2019. A graduate of the University of New South Wales in Sydney, Australia, Laura holds a bachelor's degree in ceramic engineering and an executive MBA from the University of Technology, Sydney. And with that, I will now share my screen for the recording, and all questions will be answered at the end of the presentation. One moment.
Fabulous. Okay, I'll get started. Been over here for about 6 months now in the United States, but I am still prone to using some Australian slang from time to time. I'll try and avoid doing that as much as possible for today's session. Okay, so today's session is Inspirational Global Projects, highlighting some of the most beautiful brick and clay and glass brick projects from around the world. So we'll go through 3 of those today. I'll start off by mentioning that the presentation is protected by US and international copyright laws, and reproduction, distribution, display, and use of the presentation without written permission of the speaker is prohibited. Glen-Gery is an organization that provides a wide range of different services to design professionals, both on the products, from a product standpoint and also from a support standpoint. On the product side, we're manufacturers of face brick, thin brick, and structural brick, manufactured and natural stone. We provide and manufacture pavers, glazed brick, colored and pre-blended mortars, glass brick, a range of masonry accessories, and wall systems as well. So quite a few different things you can get from Glen-Gery, and a range of experts in-house that can help you out with any project. On the support side of things, we provide different product and technical profiles for your projects. We invest heavily in our product development, so always trying to come up with new products to inspire architects to create beautiful projects. We have in-house experts that can help you out with special shapes for your projects to create angles and curves and different architectural features that you may need. We conduct a wide range of AIA presentations, one of which you're hearing today, but we have a whole range of other different topics. We've been running these webinars weekly on this Zoom channel. But if you're interested also in hosting a private presentation for your office, we can accommodate those as well, either in-house once stay-at-home orders lift, or like this via Zoom. We provide guidance and suggestions on different wall systems for your different thin brick wall systems to suit your project, review details for your projects, provide a free specification review service, in particular for our masonry accessories, and help guide specifications for your projects as well. So please get in touch with us if we can help out with any of those things. Glen-Gery is a registered provider of the Institute of Architects continuing education systems, and the credit earned on completion of the program will be reported to the CES records for all AIA members. So Brian will help you out with issuing certificates of completion for those sessions after we finish today's presentation. Okay, let's get started. So today's session is on inspirational global projects. We're looking here at 3 case studies in detail on exceptional clay, glass, and ceramic facades from around the world. Start off by just showing how all of this fits together. So at Glen-Gery and Brickworks, we are a house of brands. So Brickworks is our overall family that we all are part of, our publicly listed company in Australia. And these are how all of these brands fit together in our group. So here in North America, our predominant brand that most people will know us for is Glen-Gery, the name we operate under. We also have a number of specialty boutique brands that we offer as part of our group, including Sioux City Brick, Lawrenceville Brick, and Cushwa Brick. We scour the globe to find the best international partners to work with as well. So some of our international brands we work with here in the United States are San Anselmo and La Paloma Ceramicas and Feldhaus Clinker Brick out of Germany. And we also have a wide range of brands in our Australian group as well, both brick and concrete masonry, precast panels, and roofing, among others as part of our Australian group. So we are becoming quite a large international company with a whole range of different products and a whole lot of knowledge that we can help you with for your projects. So I'll start with the learning outcomes for today's session. So there's 3 different projects and learning outcomes for each of them. So I'll talk through that as we get started. So the first project is the Celine flagship store in Seoul, designed by Caspar Malonier. We'll look at describing the manufacturing process for the 500mm long format clay bricks used on the project and demonstrate how an open brick bond was achieved through the use of vertical rods for that project as well. The second project is Crystal Houses in Amsterdam by MVRDV. The learning outcomes for this project are to describe the steps involved in manufacturing highly precise solid glass bricks for the project and detailing the unique construction of the glass brick facade using UV cured adhesive bonding. Lastly, we'll take a look at the Australian Embassy in Bangkok, designed by BVN, identify the use of 11 different curved radial bricks for that project, and determine the timeline for production and delivery for products used in international projects. Okay, so our first project here is the beautiful Celine building in Seoul. Much of the information here comes from our manufacturing partners in Italy, San Anselmo, who were instrumental in assisting with this project. So thank you to San Anselmo for providing a lot of the detail for this presentation on this project. Starting out with some facts about the building. The project is the Celine flagship store located in Cheongdam in Seoul, South Korea. 2 predominant architecture firms working on the project, Caspar Malonier from London in the UK and Heian Architecture were the project architects in Seoul in South Korea. Manufacturer here was Fanase San Anselmo, located just outside of Venice in Italy, and the client was Louis Vuitton Moet Hennessy, who owns the Celine brand. This is a 7-story mixed-use building that was finished in January 2017. This is a flagship building for Celine. It's a 7-story mixed-use building with a stepping mass, which is unified through this simple brick envelope. The brick used is a light-colored bespoke terracotta unit that is laid with this complex bond pattern that uses different lengths and opening types to create a veiled brick skin. This resulting brick skin resembles a veil, part open, part closed, providing transparency and displaying a variety of different lighting conditions as the sun travels through the building and animates those spaces inside. At night, when the building is illuminated, you get that urban lantern effect where the building lights up with these pinpricks of light through those brick openings in the facade. Start off by describing a bit about the product that was used. This is a long format brick made in Italy with dimensions 500 by 40 by 100, or 19 and 11/16 by 1 and 9/16 by 3 and 15/16 of an inch. This is a drag wire finish, so similar to a wire cut finish you would see on a typical brick here in Bianco color, which is an Italian white color. They wanted to achieve the look of this Roman brick where you would have quite thick mortar joints. So this is about double what you would typically see for a mortar joint at 20 mils or around 13/16 of an inch to create this wider brick mortar ratio than you would typically see. Quite common in Italy and in Rome in particular. For this project, they used flush mortar joints selected both vertically and horizontally. So the brick and mortar are in line with one another, creating a unified surface without any shadowing effect. And the mortar color was selected to match the brick. So they really wanted to have this one modular look and feel to the building where the brick and the mortar blend together to create one continuous looking surface that's only broken up by these perforations in the brickwork, which create voids for light to flow through those spaces. So describing a bit of the manufacturing for the bricks here. So the San Anselmo long format bricks are handmade in La Regia in Italy. And what happens when these bricks are made is the brickmaker forms slabs of clay into these wooden molds. Each brick is made individually with different surface finishes applied afterwards to create different textures and colors on the surface using water, sands, different cutting wires, or glazes to create different looks and textures for those bricks. Because the clay used to form these bricks is so soft and the bricks are such a large size, this process cannot be automated. So it needs to be done one by hand, with love by these brickmakers in the factory in Italy. The bricks are then hand stacked onto shelves for drying. So you can see each brick individually stacked on its shelf for drying prior to being fired. So this is to make sure that all the necessary moisture is evaporated from those bricks prior to firing, and they're laid out like this individually on racks to avoid any warping that would potentially occur if they're stacked together. So this is one of the extra details that needs to happen when making these large format bricks, is to be careful to dry them and fire them in such a way to avoid any warping or distortion of the shape. They're fired at over 1,000 degrees Celsius or 1,800 degrees Fahrenheit, and can be produced in a range of different finishes. So water struck or a standard soft mud or smooth finish, a Selmo soft mud or textured finish, or an extruded smooth finish as well, depending on what the architect requires for their project. And that's the final product that you see there. So these long format bricks at a nominal 20-inch length, and have that beautiful handmade characteristic and long format that is quite unique. Having a look at the bond design for the project now. So there was a significant amount of collaboration required to achieve this intricate bond pattern for the project. So it was a joint effort between San Anselmo engineering team and Casper Malinier architects. What they were doing here was retrofitting the facade system to be installed 420 mils or 16 and 9/16 of an inch from the existing load-bearing wall. So this facade was essentially being suspended off the existing load-bearing wall of the project to create more interest than what was there previously. There were some challenging design considerations for the project. Seoul is located in an area with significant seismic regulations where it can be prone to earthquakes. So local seismic regulations required L-shaped shelf ankles to anchor the brick at each story, and vertical steel rods to connect those bricks as well. The steel rods must not be seen through the open bonds, so that created some challenges that needed to be worked through to see how you could vertically support those bricks through these steel rods and not interfere with this desire for this light and airy veiled facade that they wanted to achieve. So careful analysis and comprehensive structural study was required in order to achieve this facade in that particular location where seismic regulations were very important. In order to do that, a few prototypes were built. So having a look at how this ended up being constructed, the bricks were designed with voids in them in the core of the brick that would allow for the use of a vertical reinforcing rod. And here you can see the prototype being built there that shows how those rods fall into place. So I'll show a little video that demonstrates how that works here. So you can see the bricklayer dropping those bricks with the core holes over those vertical suspension rods and mortaring them into place. Quite a long video, so I'll skip just to a few different key sections to highlight some of the details of how this worked. So you can see him dropping those bricks down over those rods and leveling off the brickwork. Coming down over those reinforcing rods there, working up to the full height of that reinforcing rod length. And then at the top here, you can see these connectors being screwed into place. So the purpose of doing it this way is rather than dropping brick down over the full height of that reinforcing rod, which would be the full height of the story of brickwork that they're constructing, they've done it in these shorter sections, which are about a foot and a half in length. So you're not dropping those bricks so far down over those rods. Makes it a little easier to construct, doing it in these sections that are connected in place as they go. So it makes it a little bit more buildable than it otherwise would have. So you can see him going through there and adding those next sections of the reinforcing rod, and then again laying that brickwork down over those reinforcing rods to create this vertical reinforcement that allows for this construction to work under these particular seismic regulations. There we go, and that's the prototype. So that system worked very well. Nice and simple way to allow for this vertical reinforcement that doesn't interrupt that open bond pattern, which was a very important part of the facade detailing of this project and the thing that really sets this project apart as well. Okay, so in order to produce those units and allow for this facade to be constructed, 3 different lengths were required. So those core hold bricks were produced at 3 different lengths: a 500 mil length or a 19 and 11/16, a 360 mil length or a 14 and 3/16 inch, and a 220 mil or an 8 and 11/16 inch. So these are the 3 different lengths that were used on the project. They also included 13 different brick types to allow for positioning of vertical rods. So that's bricks with 4 different holes, 3 different holes, and 2 different holes, and without any holes at both the 500 mil and the 360 mil length bricks. So that 19 11/16 and the 14 and 3/16 of an inch lengths as well. The 220 mil brick, or the 8 and 11/16 inch brick, had 2 holes that were in different positions depending on where they were required in the facade. So 13 different brick types used in this intricate brick facade to make sure that they could tell the bricks apart from one another. Each brick was imprinted with a code to identify the type and position. So here you can see the T12H brick, and that allows the bricklayers to identify where this brick would be required in the facade. To aid in the construction as well, each brick was color-coded in the drawings to indicate its position in the facade. So the T1 being the magenta, the T2 being the teal, and the T3 shown in lime green there. And you can see the different positions for those core holes, as we mentioned. So you've got a 2-hole version, a 3-hole version, and a 4-hole version, depending on the degree of reinforcement required and where it's used in the facade, and a 2-hole and a 3-hole in that T2 length, and a 2-hole in that T3 length. So allowing for those rods to be inserted through those core holes in different positions in that facade as well. Suspended bricks were used in areas where the base of the brick is visible. This is something that architects come to us regularly to look at different solutions for, finding ways that you can still show the appearance of a full brick in soffit areas, the underside of window sills, or brick ceilings, that sort of thing. So they did include that detail on this project on both of those different brick length types, so the T1, the T2, and the T3. Installing off the shelf angle this stirrup that allows these suspended bricks to be secured back up to that shelf angle. So make sure that this piece is mechanically fixed to that shelf angle and is a structural part of the facade, but also provides the appearance that this is a continuing piece of that brick facade and creates a nice architectural detail underneath that brick skin, where you get this continual brick surface wrapping around. Very nice detailing there. Oh, and they refer to this type of brickwork, I don't know if I hear it used too often here, as a brise soleil, which is like a sun veil, allowing the brick to create this light and shadowing effect, allowing breezes to flow through. I also hear it called hit and miss brickwork, is one of the other terms often used to describe this type of brickwork, where you've got openings in the brickwork creating this void effect. A brick facade construction manual was provided to the local bricklayers on the project. So each morning, those bricklayers were given a page from the manual with specific instructions for each day's work. And the manufacturers at San Anselmo supervised the initial phase of installation as well, to make sure that the right bricks were going in the right places for the project. So what you can see here is a page from that manual and showing the different courses to be constructed that day, the color coding for the different length units required, to show which section they needed to work through for the day and which bricks needed to go into which positions. You can see an elevation and section of that facade showing how that brise soleil or brick veil is suspended off the existing facade, creating this light, airy brick veil, which is interesting to see in a material that is so typically perceived as being heavy. Creates this perception of lightness with the way that it appears to hang and allow light through. Another detail there showing the section and elevation, and you can see the brickwork where the locations are for all of those vertical reinforcing rods in that structure as well, that allows for it to be constructed in what looks like such a open bond that actually has these vertical reinforcements to hold it in place and prevent it from destabilizing. One of the things that does typically make brickwork very strong is the way that it interlocks. So the way that bricks interlock with each other, forming a strong interlocking net. By opening up the brickwork, you're destabilizing that bond. So by ensuring these vertical rods are reinforcing the brickwork, they're making sure that it will be stabilized and will not move through any of those seismic movements that can occur in South Korea. Okay, here are some shots of the brickwork as it's being installed on site. The vertical rods were welded to that L-shaped shelf angle on the slab level of each floor as it's under construction. Each vertical rod was 8 feet in length and threaded so that they could be joined with a long bolt. As we saw as they were constructing that prototype, They had this threaded rod with this bolt at the top that allows each rod to be connected to the next one above. Given those thick mortar joints compared to the thickness of the bricks, there was a limit on the number of courses that could be laid each day with fresh, undried mortar. To help this process and to speed it up, a neoprene spacer was used between the bricks in order to support the weight. So as that mortar is drying and curing, they were using a spacer between the bricks to support the weight of the course above, to allow construction to continue as that mortar is curing and drying. The first story was hung on those L-shaped horizontal anchors to allow that from below, no anchoring system would be seen. So as we saw here, those stirrups were installed so that you wouldn't see the bottom of that L-shaped anchor. You would just see the surface of the brick, making it look like a one continuous material as it goes up. Few more shots from the brickwork as it's under construction. You can see the bricklayer here screwing on that connecting bolt before starting the next story, and the thickness of those mortar joints that has that Roman look to it. And that's the completed building as it stands today. So you can see that urban lantern effect we were describing earlier on, where at night it lights up with the little pinpricks of light between those perforations in the brickwork, really making it appear like this light floating material as it extends upwards to the top of the facade. Solers has some of the most beautiful brick architecture, and particularly modern brick architecture. So I'd love to get over there and visit a few of these projects. This one in particular is absolutely stunning. Okay, moving on to our second case study. So our next project is crystal houses designed by MVRDV. Much of the technical information here comes from an academic paper, The Construction of Crystal Houses Facade, Challenges and Innovations, by Oikonomopoulos et al., published in the Journal of Glass Structures and Engineering in 2018. And the research work was conducted by the TU Delft Glass and Transparency Lab, whose permission to republish the results is gratefully acknowledged. MVRDV and Giedemans and Van Dyck are responsible for the architectural design, ABT for the structural simulations, Vessels Zeist for the construction of the facade, and Poesia for the manufacturing of the glass bricks. So quite a extensive technical team involved in this project, more than you would typically see for your average glass brick building. But this is not your average building. Okay, so starting off with a few facts about the project. So the project name is Crystal House, located in Amsterdam in the Netherlands. Architect of record is MVRDV, based in Rotterdam in the Netherlands. The manufacturer was Poesia from Venice, Italy. And the glass brick facade component is 10 meters by 12 meters, or roughly 33 feet by 40 feet. This project was completed in 2016. So the product used on the project is the Venetian glass bricks. The finish was a polished finish with custom-made cast glass elements for windows and door frames. They even had custom-made cast glass door handles. So even the doorknobs are made from solid glass. Everything on this project that they could make glass, they made it out of glass. It's absolutely beautiful project. Over 6,500 solid glass bricks were used on the project. They were predominantly two dimensions. They're based on a European format, which is 210 by 105 by 65 millimeters, or roughly 8¼ inches by 4 1/8 inches by 2 9/16 of an inch. They also had a double width brick, which was 210 by 210 by 65, or 8¼ by 8¼ by 2 9/16 of an inch. So one single width and one double width used to create the patterning of this glass brick facade. Here's an illustration by MVRDV of the concept behind the Crystal House facade. So what happened and why the developer wanted to reevaluate this facade and do something different was updated zoning laws had occurred in Amsterdam at the time on this particular area, which is a heritage area of central Amsterdam, which allowed for increased heights to the buildings in this particular heritage area. So what the architects designed was this stretching of the facade upwards that allows them to make the most of that new height they could use in that area while still maintaining Amsterdam's traditional architectural style. The innovative facade follows the original 19th century elevation down to the layering of the bricks and the details of the window frames, which is stretched vertically to comply with those updated zoning laws and allow for increased interior spaces. As it ascends, terracotta bricks intermingle with those glass bricks, gradually transforming the glass elevation of the traditional brick facade onto the upper floors. So it's almost like the building has been pulled upwards, and that glass brick at the base of the building is the space that's being created by pulling the building upwards from the roof. In order to achieve the design intent for the project, 3 factors defining the structural performance and transparency level of the facade needed to be considered. So at that point, they were looking at a choice between a hollow or a solid glass brick. So you can see different types of glass bricks on the market. Hollow bricks tend to have a void internally, and the solid glass bricks are a solid, heavy glass unit. The choice between whether a structural adhesive bonding or some kind of supporting substructure would be required for the design and the facade's overall geometry. Now, the most important thing the architects wanted for this facade was to make sure that it was as transparent as possible. So by having a polished solid glass brick, you're getting the most transparent type of glass brick you can get on a project. Any kind of voids or inclusions in that glass will diffract the light as it's flowing between the bricks, and you will see that you don't get the same level of transparency. You get almost a translucency with other types of glass finishes or other types of glass brick units. The choice between a structural adhesive bonding or a supporting substructure was also considered. So a supporting substructure, what I've seen used on some other glass brick projects would be having the vertical and horizontal steel reinforcements for the project. Again, that would impede the transmission of light through those glass bricks if you've got steel support structures behind them. They wanted this to be as transparent as possible. So avoiding any of those supporting substructures was critical for this project, which in turn shows that they would require some kind of adhesive bonding to create a structural monolithic facade manufactured with these glass bricks. In order to do that, they went back to more traditional masonry techniques, which is the use of these buttresses. So they used full glass brick constructed buttresses, which form the support for that facade. There's 4 supporting buttresses along that facade of the building, which interlocks with those bricks on the facade elevation, increasing rigidity and providing a structural backing for that facade. So you can see here those solid glass bricks and how they turn to create these buttresses and support that facade. You can also see the 2 different widths of the bricks. So you got those standard width bricks, as well as the double width units that were used to create this bond pattern and this facade width as well. Moving on to how these glass bricks are made. So each brick is made individually by pouring malted glass into high precision open steel molds. A low iron glass recipe is used to make these bricks to allow for high optical quality. Steel molds are preheated to a constant temperature of 650 to 750 degrees Celsius to allow for a smooth surface texture. So what they're looking for here is what we call a Goldilocks temperature. So not too hot and not too cold. If the mold temperature falls below 650 degrees, the hot glass comes in contact with a metal surface and freezes instantly, creating a rippled and wavy surface. If the mold is heated too hot, so above this 750 degrees Celsius temperature, the glass can stick to the walls of the mold and be more difficult to release. A release coating is used on the mold to further prevent sticking of the glass and the formation of micro cracks. So you can see the glass brick makers here pouring that molten glass into the mold there. And this gentleman here literally is shearing off the base of that glass, molten glass, as it enters the mold. So these guys have been doing this for a very long time. They're experienced, knowing how much glass needs to go in the mold to create each brick, and they can tell by weight and feel when that glass is ready to be snipped off and the next one to be created. If you've ever been to Murano, just off the side of island off the island of Venice, you can see similar types of glass making techniques. It's a very traditional type of glass making you'll see in Italy. Bit more on the glass brick making here. So after the glass is poured into the mold, it is left at an ambient temperature to rapidly cool. This rapid cooling is essential to avoid the molecular structure from crystallizing and turning cloudy. So it needs to cool rapidly so that it can maintain its transparency. The glass is then removed via suction at the top surface and transferred into an annealing oven. The molds are designed with a removable bottom surface so that they can be easily removed and at this phase, at the end of this rapid cooling phase. So here you can see some of those glass bricks being formed there in the molds. And here you can see a solid glass lintel for the project being formed as well. You can see a bit more of the production line of those glass bricks as they're moving through that rapid cooling phase. On the left here, you can see those high precision open steel molds that are used to create the glass bricks. And then on the right, the molten glass bricks during that rapid cooling phase as they rapidly cool down to ambient temperature. You can see the color of the molten glass cooling as it rapidly goes through that process as well, from that gold, glowing molten look of the molten glass through to the fully transparent glass you would see at the end of that production line. Next, those glass bricks are transferred into an annealing oven to remove stresses and strains in the glass. It's a long controlled process around 500 to 600 degrees, which is around 932 to 1112 degrees Fahrenheit. So depending on the size of the glass unit required, there's different annealing times that are necessary for the brick. So for the single width brick, they needed to be in that annealing oven for 8 hours. And then for that double width unit, they're needing 36 to 38 hours in that annealing oven to fully ensure that those stresses and strains are removed from the glass. Analysis of those strain concentrations was conducted using a polarization test. So this polarization test transmits a white light source and crossed polarized form to block the transmission of light. And the bricks with stresses will distort the light that's flowing through those bricks. So bricks on the left here, you can see there are some residual stresses which are distorting the light, and you can see, they're creating these stress concentrations in the brick, which are very visible when you conduct this test, compared with the brick on the right, which has no visible strain concentration. So basically what they're doing at this point is using light to check for stresses and strains in the brick. If they're seeing stresses and strains, those bricks will be discarded, and those without stresses and strains are employed on the project. Okay. Next up, we'll start talking about the laying of those glass bricks. So a bonding agent was required to adhere these bricks together as they wanted the facade to perform as a monolithic unit. So like one solid single piece of glass. In order to do that, they needed to work with a particular transparent adhesive that could be used to glue those bricks together. This bonding agent, as a result, needed the precision of those bricks to be highly accurate. So each brick had to be within 0.25 millimeters of the stated height, or 1/100th of an inch. Typical brick tolerances would allow for roughly 3 mil or plus or minus 1/8 of an inch. This project needed those bricks to be within 100th of an inch, so very, very highly accurate in their height. In some cases, post-processing of that horizontal bonding surface was used to ensure accuracy. So essentially polishing and grinding down those top and bottom surfaces to make sure the bricks are perfectly level, and they're also within these very, very strict size tolerances for the project. To bond the bricks together, an adhesive joint of 0.2 to 0.3 mil was used, or again, roughly 100th of an inch for that adhesive as well. The high precision was required as mortar joints cannot accommodate tolerances in this case. So what you would typically see on a clay brick project is you'll have some degree of variation in the size of the bricks resulting from the firing of a natural clay material, which can cause some size variation. Some bricks end up a little larger, some bricks end up a little smaller, depending on where they're located in the kiln during firing. And the mortar joint allows you to accommodate that. So you could have a slightly smaller mortar joint if your bricks are a little taller, or a slightly shorter mortar joint if your bricks are a little tall. So if you've got a brick that's a little bit bigger than usual, you can have a slightly smaller mortar joint to accommodate that, and vice versa. But on this project, they weren't able to do that as the adhesive joint needed to be so narrow. The bricks also needed to be so accurate so that they were all perfectly level, allowing that adhesive to sit in place. So 2 separate dimensional controls were used to determine conformity, performed first at Poesia and then at the University of Delft for verification, using cut metal jigs to control the total length and width of the brick, and also electromechanical measurements, taking point measurements to check that they are accurate in height and flatness. So very, very highly precise brickwork was required for this project. They then sorted the bricks into a range of acceptable heights. So the bricks that were 1/100th of an inch undersize were sorted into group A category, and the bricks that were 1/100th of an inch oversize were sorted into a group B category, and then only bricks from each of those categories used to lay each course to make sure that they never had more than 1/100th of an inch variance in each course of brickwork. A little bit more about the adhesive used on the project. The adhesive used was Dello Photobond 4468. It is a colorless UV curing 1-component acrylate designed for high strength bonding between glass components. And that material allows the facade to perform as a single rigid monolithic element. Has a similar refractive index to glass, which was very important as they wanted there to be no appearance of the adhesive in those joints between the brick. So you can't see this adhesive in those joints. It has the same look as the glass on either side. It does not discolor over time, and it is moisture and water resistant after 40 seconds. This is another challenge that you can see on projects where they want to use silicon mortar joints. Some silicon joints will discolor over time. And if you had that in an area where it's exposed to a lot of sun or UV light, you can see the silicon joints start to discolor, start to yellow over time. So by using this particular adhesive, they were able to ensure that the joints between the bricks would always look as good as they did on the day they were laid. Moving on to the construction now. Upper conventional masonry facade was built first. So you can see this piece at the top of the wall there was the first piece done, supported by a steel beam spanning the length, with a highly skilled building crew and strictly controlled construction. So 7 to 9 skilled workers working 12 hours a day, 5 days a week. bonding and sealing on average 80 to 100 bricks per day, and they were constructed within a UV filtering tent to protect against solar radiation, weather, and dust. So they really didn't want any dust or dirt sitting inside the layers between those bricks and being visible and causing little inclusions and, you know, being visible inside those joints. It was also built on top of a reinforced concrete plinth. So this is a, commercial street of Amsterdam. So there's lots of retail stores right up against it, and, you know, cars and bikes traveling regularly across here. So they wanted to make sure that the glass wasn't used on the absolute ground level of the construction. They had this concrete plinth in case any impact occurred. The glass bricks were above the point of impact. Next, you can see the bonding of those bricks. So from left to right, what you can see here is this X frame that was used to provide the pattern for the adhesive. That frame was taken away, and you can just see the X pattern that's resulting from that in the adhesive. The adhesive was UV cured with a UV beam initially to prevent capillary action, and then a UV lamp used to cure the adhesive for 60 to 120 seconds afterwards. Only the horizontal elements on this project were bonded. The vertical were left open, allowing for thermal expansion of the glass on the facade. So this X pattern allowed for when the next brick is laid on it, the X flows outwards, allowing for, you know, that thin adhesive joint to be laid. Next, you can see where the bricks transition into the clay for the facade above. So it's transitioning from the glass to the clay to create this nice gradient effect. The challenge on doing that was there are different mechanical properties and variations in acceptable tolerances between glass and clay units, and different bonding required between brick types and different adhesives. So these clay bricks like to be mortared together. We know these glass bricks are being adhered. So what they did to get around that was create some glass brick units that were a little shorter in the wall, which allowed then for these clay units to be adhered in front of that glass unit. So they're not actually intermingled, they're just designed to appear that way, with these clay brick facing units adhered to the glass to create the appearance of that transition. And there we go. That is the completed project as it stands today on the streets of Amsterdam. Actually, it's not exactly how it stands today, as a few years after Chanel moved in there, it changed hands and is now the home of Hermes, for the flagship store for Hermes in Amsterdam. Okay, now the last project we'll chat about today is the Australian Embassy in Bangkok. Starting off with a few facts about this project. So this is the Australian Embassy Bangkok in Bangkok, Thailand, designed by BVN architects from Australia, manufactured by Barrel Bricks in Australia, built by Boyges Thai VSL. It was 194 million construction for this project, completed in 2016, with an architect team led by James Gross, Peter Clark, and Asher Galvin at BVN. So why did they need a new embassy in Thailand? The Department of Foreign Affairs and Trade conducted an audit of embassy buildings globally around the world to check for the safety and risk of different terror attacks and safety risks that could occur on these DFAT buildings. Embassies typically have a 50-year lifespan. The old embassy was completed in 1979, designed by Ken Woolley, but had been noted to have some security flaws in the design. Creating this new embassy for Thailand became the fourth largest diplomatic mission in the world for Thailand, as there is a significant amount of foreign affairs and trade between the two nations. Here you can see that brick architecture and the use of brick in design has a strong history throughout Thai culture, used extensively with these Itmon Dang bricks used in Thai temples and various construction projects around the country. So they're a very popular type of brick in construction in Thailand. Few details about the products used on this project. It was a dry press brick using 3 different colors, a red, a blue, and a gray. Designed in Australian dimensions. So this project is on Australian soil in Thailand, made with Australian bricks with Australian dimensions. Australian bricks are a little larger than typical US bricks. So they're a 230 by 110 by 76, which is a 9 1/16 by 4 5/16 by 3-inch unit. Closest size that I can find is probably a handmade oversize, is the most similar to the Australian brick dimension. There were 19 different special shapes used on the project with 11 different radial bricks, and the use of brick references Thailand's traditional Itmon Dang bricks, which are these bricks you see used throughout temples and historical sites in Thailand. Having a look at the design, the embassy was designed to be a piece of Australia in Thailand, using Australian materials and a colour palette directly inspired by the outback. The red brickwork and the unusual shape create a silhouette reminiscent of Australia's greatest landmark, Uluru. So, according to James Gross, this was the reason for the design. And when you look at the building as it sits in the landscape of Bangkok, it is this sort of big red rock that really makes you think of Uluru, that big red rock out in the middle of the outback in Central Australia. So it has that evocative feeling of Uluru. I definitely get that impression from how it looks. A few details on the layout of the building. So this is the main embassy building here, which is the chancery for the Australian embassy. There are also 2 other buildings used in the embassy, which is the entry and guardhouse, SER, at the front here, and also the head of mission, which is the ambassador's quarters. Having a look at some of the special shapes now. So these are all of the different radial bricks that were used to form the curves of the building, ranging from 4,775 millimeter radius down to a 595 in the blue colored brick. There are also some squints and mitered bats used to form different angles on the project as well. In the red color, again, you've got a whole range of different radiuses, from a 5,000 millimeter radius down to a 545 millimeter radius, and a trapezoidal brick, which is used in some areas to form the curves, and this transition brick as well, which is used to transition from a curved wall to a straight wall using a brick that is half curved and half straight. And lastly, for the guardhouse, there was no special shape used, just the standard brick unit. Having a look at the project in plan here, you can see how those different radial bricks are positioned to form this curved structure, this curved facade, which uses all these different radial bricks to form these gentle curves around the perimeter of the building. So from a 5,000 millimeter radius, which is a really subtle curve, down to that 545, which was the smallest radius used on the project for these tight internal radial curves that you see here. Supplying bricks for international projects requires a tight fabrication schedule. So having a look here, you can see the schedule for the brickwork, from the construction of a variety of mock-ups, training of the Thai bricklayers to be able to lay this particular facade, and then from a manufacturer's perspective, creating a stockpile to create a bespoke colour, doing different trials on the colour to try and achieve this deep earthy red that the architect wanted, accepting that colour from the architectural team, tooling the different dyes to make the special shapes, production of those different bricks, testing to make sure that they meet the codes and standards required for the project, shipment from Australia to Thailand, and then delivery to site. So different colour trials used to create the different colours for this building. The red in particular was a new colour that had never been made before, really wanting to evoke that red earth of the Australian outback, called the Embassy Red. So it has this beautiful earthy red tone. Also shows the range of acceptable colors for that brick. So, ranging from a slightly lighter orangey tone to a deeper red. Similarly for the blues on the project, from a brownish blue through to a deep, darker blue. In order to produce these special shapes, molds were made out of case hardened steel. So you can see on the left there, the mold for what is a 595 mil radius brick. So that's quite a tight curved brick. And what's nice about these bricks is you can use both the internal curve and the external curve to create two different radiuses depending on how they're designed to be used. And to allow for the bricklayers to know which bricks needed to go in which positions, in the frog of the brick was pressed in the radius. So here you can see R595, showing that it's a radius 595 brick, so they know where it needs to go in the building. The facility that produced these bricks is a highly automated facility. So one of the challenges creating a radial brick like this is that there are no rectilinear surfaces, so no straight edges that a robot, which would typically pick up the bricks at the edges, was unable to actually lift these bricks. So what was done for this project was the use of suction heads. So on the robots were installed these suction heads that would suck up the bricks and move them from the production line to allow them to be transported safely without any chippage or breakage. So I'll show a few little videos here showing those bricks being transferred using those suction heads. So you can see the suction head dropping the bricks down there, picking them up here. There we go. And moving them safely without any chippage. It's a highly automated facility, meaning there are no hand labor on site, so it's all fully automated. So the first person to touch the brick is the bricklayer that handles the brick on site. There's no human contact with the brick up until that point for this particular factory. And a little bit of trivia about barrel bricks. All of the robots are named after the Adams family. So you can see Wednesday Adams and Pugsley Adams, the two robots shown in this video. Okay, next up here we can see we're checking those radiuses to make sure that they're meeting the stated radius of the brick. So what we're doing here is measuring out circles of the correct radius, laying the bricks along that radial curve, and making sure that they're achieving the stated radius. So making sure that they are accurate in achieving the correct curve for the project. So you can see the different radiuses used throughout, demonstrated in these little mock-ups here. And the three different colors, the gray, the blue, and the red. This is my favorite, the barrel blue, beautiful color. Okay, moving on to packaging. So challenging for sending bricks from one country to another is that they're heavy, they knock against each other, they rub. In order to prevent that for this project, layers of cardboard were used between each layer of brickwork and between courses of special shapes to prevent them from knocking against each other and rubbing during transportation. Prototypes were also built for this project. You can see here they're prototyping, checking the curvature. This is a little visual mock-up, and also checking these sophites where the bricks are installed under the windowsills, checking that detail as well. Looks beautiful. The walls of this project are very, very thick, which you saw in that last image, the depth of those window reveals. The project needed to be blast proof to avoid any blast that could occur. So they have a 1 foot wide concrete shell forming the structure of the building, with the bricks as a facade, a facade only. They're not a structural part of the the embassy itself. The walls had to be blast proof, so the concrete was typically a foot in width, with the total wall buildup of the concrete, the cavity, and the brick over 3 feet in width, forming this secure embassy shell. That's the formwork there, used to create the curves in that concrete on the project. And moving on to the bricklaying. So one of the biggest challenges was there was a largely untrained Thai labour force required to produce work to Australian codes and standards for the project. Thai construction relies on large numbers of manual labour rather than technical innovation, creating great pressure on the quality control. So a large international construction team with many different cultural backgrounds had to work together to construct this in Thailand to codes and standards from Australia. So the bricklayers did an incredible job on this project, meticulously laying these different curves in the building and making sure that every detail was to Australian standards. So they did an exceptional job, the Thai bricklayers on this project. And interestingly, many of the bricklayers on the project were female. So female bricklayers played a major role in the construction of the Australian Embassy in Bangkok, where 3 South Australian bricklayers led the build, training and supervising of that Thai local workforce. The contractor for the project employed over 600 construction workers, with almost half of that workforce being women. Rather than simply being involved in the lighter tasks, the women were firmly embedded in the construction process, from steel fixing, scaffold assembly, to concreting and formworking. More than half of the bricklayers were women, and the site foreman mentioned that they were some of the most highly detailed of the bricklayers on site, entrusted with the building's complex curves and geometries. Matt, who was the foreman there, attributes that to a great attention to detail and willingness to learn from the Australian team. Given the language and cultural barriers that both the Thais and the Aussies encountered every day, finding ways to communicate became essential to make sure that great work was produced on this project. And it absolutely was, from the architectural team, through the engineering team, through those Thai bricklayers on site, creating an exceptional outcome for this project. And there you can see the completed building as it stands today. That beautiful curved brickwork with all those different radial bricks forming these soft, gentle curves as you move around the facade of the building, with these deep window reveals that emphasize the mass of the material and also provide security for the embassy itself. Okay, that officially concludes our AIA continuing education program for today. We will now throw to any questions. So if you have any questions on any of these projects today or any questions for us, please go ahead and type them in the Q&A box.
Thanks everyone so much for tuning in. I can see questions come through from John on the Celine building. Problems with openings becoming bird nests. How are windows about 16 inches behind the facade cleaned? Yes, practical things need to be answered in every design. That's a great question, John. And in my experience, particularly with the bird nesting behind the facade, on another project I'm familiar with, the Tate Modern Switch House in London, UK, they actually ensured that the openings of those perforations in the brickwork were small enough that native birds in the area couldn't nest in those openings. I'm not sure if they did the same thing for the Celine building, but the openings are about the same size or smaller, so it's possible they chose the opening size to limit the attractiveness of those spaces for bird nests. And also about the window cleaning. So the windows are steam cleaned behind that facade. I don't think that would be as effective as abseiling and squeegeeing off those windows, but good way to get behind that brickwork and make sure you have as clean a surface as possible to get rid of that dirt and grime. Okay, then I see a question here from Charlie. Where is the blue brick in the embassy project? The blue brick is really in a part of the building that's not as regularly shown. It's the ambassador's quarters. I don't know that I have any images of that in this particular project, but if you Google it, you should be able to see some of the shots of those barreled blue bricks used in the ambassador's private residence. Okay. Doug has a question about what is the approximate cost per square foot for the 3 facades. That is a tricky question. They are all private projects with the exception of the embassy. So all 3 of them are specialty projects. You need skilled masons to lay them. If you're looking at doing a project like this in your area, I would talk to the team at Glen-Gery, get some advice on it. We can advise you on rates in your local area and get some advice from local masons on indicative pricing. But yes, I would say all 3 would be much higher than your standard rates per square foot for a typical commercial project. Okay, I'm seeing another question. Patrick has a question. Can the blue glass brick be used on the floor outside to mimic water? That is an interesting question. So we had one project in Hong Kong, the Aesop, it's a skincare store in Hong Kong, which used our glass bricks throughout the walls and the floor of the storefront. In Hong Kong, it was fine to use them, but in the US, they do tend to be quite slippery, so you wouldn't pass your slip rating requirements to be used in a commercial flooring application. So maybe in your own private home if you're not worried about slipping, but I wouldn't recommend them on flooring unless you apply some kind of wax sealant or something to provide a bit of extra traction so that you don't run the risk of people slipping and falling if the area becomes wet. Kent Darrell asks, does Glen-Gery own Poesia Glass? No, we work with a variety of international manufacturers for importing specialty products from around the world. So no, we do not own Poesia Glass, but we are in partnership with a variety of manufacturers. Okay. Greg Smith, is the glass brick project, are the edges eased to aid in install and avoid chipping? So the way that the glass forms in the molds creates quite a soft surface on those edges. So on the vertical edges in particular, on the Crystal Houses project, the top edges were ground down to create a more flat surface. So there would be more of a sharper edge on that top surface, I would say, but typically they do have more of a rounded edge, which does help with chipping and creates a nice soft finish. It makes it easier to clean as well. Malcolm Dixon has a question. Are there any bricks and techniques which are better for impact on sustainability and reuse? What's great about masonry materials, brick in particular, is that they can be recycled over and over and over again. Bricks can be used and reused for over 100 years if they're still in good condition. So the embodied energy used to make them at the point of manufacture can have a very, very, very long life. So over the lifetime of a project or several projects, they can be reused and reused, recycled. They can be ground into road base or infill for new communities and builder developments. So there is good reuse of the material. For sustainability, they do have a higher degree of thermal mass than some of your lightweight materials. So they will help with your energy efficiency in buildings. And we do have a number at Glen-Gery of very highly efficient factories, our Lawrenceville, our Pittsburgh, and our Adel factories in particular, being very highly automated, very efficient, which will aid in their embodied energy as well. If you have any further questions on that, we'd be happy to send through some more information. So please get in touch via our events at Glen-Gery, Malcolm, and we can help you out with any other questions you may have. Last one I can see here is from Teresa, on the glass facade, how about meeting the energy requirements? Is the thickness enough to make up for the U value of glazing? I believe yes, on the Crystal Houses project, it is a double width glass facade. So yes, that will help with meeting that U value for glazing for that project. On other projects, I've seen additional energy efficiency light bulbs and air handling in the building behind the facade to allow for that energy requirement, but each project will be different. So again, if you need any help or advice on your projects, our technical team here at Glen-Gery can assist you with anything that might come up if you're thinking about using glass brick for your next job. Okay, that concludes all of our questions for today. Thank you all so much for tuning in. If you'd like to come and visit us, we have new locations open. We opened our beautiful new Brickworks Supply Center at Northwest Urbandale Drive in Des Moines last week. So if you're in the Midwest area, please stop by and see us there. Come and see us here in Philadelphia or at one of our new locations coming soon in New York and Baltimore. Thanks so much for tuning in, everyone, and have a great week.